Okay, welcome back to the tutorials. Now this whole section of tutorials is going to be on mole calculations, so I'm going to do a sequence of them starting with balancing equations. Now balancing equations kind of underpins all the work we'll do with this thing known as mole calculations. So let's get started. I'm going to call this mole calculations tutorial A. Okay, so what do we mean by balancing equations? Well, we need to be able to write formula, and from the formula we can then look at the reactants and the products and see how many atoms we have on each side of the reaction, and then try to balance. So let's have a little as an example. Let's take magnesium metal reacting with oxygen. All right, so this is the reactants on the left, and that's going to form, I'm hoping you might work out, it's going to form a compound, and that compound is magnesium oxide. Okay, and this now is going to be classed as my product. The compound that is formed is the product. Now word equations are quite easy to work with. Now the skill now is to put it into formula, into a symbol equation that we can work with. So magnesium, if you've got your periodic table, you know magnesium is Mg, so that's the symbol that we're going to give it. When it's a metal on its own, it's an atom, has no charge, so we keep it as Mg, no charge required. You may remember oxygen, O, here it is, will need to go round in pairs because of covalent bonding. Check out the bonding video there, and that will give us MgO2. And finally, now we've got going on over here is magnesium oxide, and you may remember that magnesium is a metal and oxygen's a non-metal, and when it's like that it's going to form something called an ionic compound. And from an ionic compound we know that it's going to be Mg is going to be +2 because it's in group 2, and the oxygen or oxide is in group 6, so it's -2. So you have Mg right at the top here, Mg2+ and O2-. They simply cancel out to make a formula of MgO. Okay, so there we are. There's our magnesium and oxygen reacting for making magnesium oxide. So that is the formula that's generated from ionic bonding. If you're unsure about covalent and ionic bonding, go and check out the videos on them earlier in the series. Last little thing we can do with this symbol equation before we try to balance it is to put state symbols in. Now you might remember that a state symbol is represented by a small letter, and this one's a subscript S because magnesium is a solid, it's a solid metal. You will remember that oxygen is a gas at room temperature, weak intermolecular forces between the molecules, Mg, and so it's O2G. Magnesium oxide, ionic compound, high melting boiling points, so at room temperature it's going to be a solid S. Okay, now let's look at our balancing of this equation. So this is kind of where we want it to balance, if you like. On my reactants and my products, I want the same number of magnesiums and oxygens on both sides. A couple of ways you can do it. I'll show you both versions to see it. The first way some people like, because you can kind of draw it out and see what's happening here. So we've got magnesium here, yes, so I'm going to represent a magnesium here as a black ball, one magnesium atom, if you like, so one lot of magnesium there. Now the oxygen is going round in pairs. That little 2 means they're joining together, so we join. It's now a molecule because atoms have joined together, so I'm doing it as a blue ball to represent each oxygen atom linking together to make 2 lots of oxygen together there. Okay, now let's go and look on the other side, on the product side, on the right hand side. Now I've got one magnesium atom or ion here linking to one lot of oxide ions. All right, so they're joined together, if you like. There we are. So here we are, having a look. You might think, oh, do you know what? I've got one magnesium. I've got another magnesium here. That's okay. There's one on each side. That should look good. 2 oxygens here. Oh, but only one here. Oh, I'll just change the formula. I'll just go here and put a little 2. Everything will be good. Right, you're not allowed to change the formula. This MgO is formed from magnesium ions and oxide ions. You can't change the rules of ionic bonding. It has to stay as magnesium oxide. So we're not allowed to change the formulas. Please don't do that. In the exam you will clearly lose marks and it's all wrong. So don't change the formula. We have to come up with another way round it. So the only way round it really is to try to make another oxygen on this side, and the only way we can do another oxygen on this side is to take another magnesium oxide. We need another one of those. By doing that, we are now able to have 1, 2 oxygens and 2 oxygens. Now that has managed to balance those up, which is great. So what we will do to remind ourselves that we've just done that, this is where we use big numbers. We use the big numbers in front of the formula, because this means everything in that formula is now times by 2. So we've got 2 magnesiums, 1, 2, and 2 oxygens, 1, 2 oxygens. Okay. The more observant amongst you will realise that we've created an imbalance here as well with the magnesiums. Now, you will often do this. This will often occur by doing an imbalance in the magnesiums. Okay, so what we then need to do is draw another magnesium down here like so, and by doing that we put a big 2 in front of the Mg. We have now got 2 magnesiums, 1, 2, 1, 2. We are now balanced. Okay, so happy to see that completed. Now the other thing that we can now try to do is to try a slightly different method of balancing. This is drawing out the particles. If you like that method, then you can continue with it. I will show you another version of it though. Let's go back to the magnesium again. Okay, Mg plus O2 goes to Mg O. Okay, now again I'm going to try to balance it, so I want the same number on both sides. So we've got our reactants again and we've got our products. This time I'm just going to write down, list underneath what I've got. I've got Mg equals 1 because there's 1 of them, and the oxygen O, there's 2 of them, so I'm going to put 2. Over on this side I'm going to put Mg equals 1 of those and O equals 1. Okay, so I've got the same problem as I had before, and we get round that exactly what we did before, realizing that I've got 2 oxygens here and only 1 here. Therefore I'm going to put a large 2. I'm not allowed to change the formula obviously, so I'm going to put a large 2 in front of MgO. By so doing, I change the number of magnesiums and the oxygens, so I will cross through the 1, and now I've got 2 oxygens. I will cross through the 1 for magnesium, and now I've got 2 lots of magnesium, so I've got the 2 there. Okay, so now I'm happy that I've managed to sort out my oxygens. I now go back to the left hand side to the reactants and try to sort that one out. I can clearly easily sort that one out by putting a big 2 in front of the magnesium. Okay, don't be tempted in either case to put a little 2 on the magnesium, because that would mean 2 magnesium atoms joined together, and that's not the case. They're separated out. So I put there 2. We have balanced it. We are good to go. So both methods will work. Okay, so shall we try another one? I'll try 2 more and I'll give you one to have a go at in your own time before we move on to the next tutorial. Let's look at sodium plus oxygen O2. Now that goes to form sodium oxide. Now the formula for sodium oxide, if we remember, is an ionic compound, metal with non-metal. Sodium is in group 1, so sodium is going to have an Na plus charge on it, +1. The oxygen, you remember from before, was in group 6, so it's O2 minus. I want to have a balanced formula, so I drop and swap. It's the quickest way of doing it. So I end up with 2 sodiums, Na little 2, to tell me I've got need 2 of them, and I've got the 1 oxygen, Na2O. Okay, so let's try to balance this one up like we did before. Now I'm going to use this method. It's just the one that I prefer to use because it's you get the hang of it, and it's less, I'm lazy, it's less drawing out, to be honest. So here we go, sodium, that's one of those, just one, and oxygen, as you can clearly see on the reactants on the left hand side, that is 2. Okay, so let's go on the other side. Now here we got a bit, I can see a problem straight away. Now I've got 2 sodiums but only 1 oxygen. Okay, so clearly I've got a problem with both of them. I think the first one I'm going to start with is the oxygen. Let's try to sort that one out, because I've got a 2 there and a 1 there. Obviously not allowed to change the formula, so the only way round it, it's a bit of trial and error, to be honest. If it goes wrong, don't worry, just go back and try again afterwards, but you've got to give it a go. Yeah, so we're going to try, I'm going to put a 2 in front there, because if I put a 2 in front, clearly now I've got 2 lots of the 1 oxygen. That's 2 oxygens there. I'll cross that through and make sure that's 2. Well, I've balanced that side, but I've done something to my sodiums. Now my sodiums, if you look at it, I've got 2 times the little 2 there. 2 times 2, I'm hoping we know that's going to be 4. I've got 4 of those now. So I go back and look at this side. I've only got 1, but I can quite easily sort that out now, can't I? Because if I put a 4 in front of the sodium, I have now balanced it all up. Are you okay with that? You can see the process. Hopefully that wasn't too arduous and too difficult to see. Let's try one more. Okay, another little trick of the trade coming up, hopefully. So this one is going to be with iron plus oxygen, and this time it's O2 again, going around in pairs. Now the formula for iron oxide, in this case I'm going to make it Fe, sorry, I'm going to make it Fe little 2 O3. Okay, Fe2 O3. Get that, if I can focus that a little bit better for you, get that a bit closer in so you can see it. Right, let's have a little look at what we've got going on here. So we do, can we go back to my preferred method where I go Fe, I've got 1 of those, yeah, just 1. Oxygen O, I've got 2 of those. Over here we go back onto the product side, onto the right hand side, that's Fe equals 2, there's 2 of those, and oxygen equals, as you see, you can't see where my finger is in the way, sorry, it's 3 there. So now we look here, now this is where I would start, because looking at the oxygens, I need the same number of oxygens on the left hand side as on the right hand side. I need to make that work. Okay, so 2 and a 3, that's never ever going to work, because I've got an even number and an odd number. An even number will only ever go into an even number, so to get anywhere on this one I've got to turn the odd number into an even number, and the only way I can do that to start with, again, it is all trial and error, so you give it a go, and if it goes wrong you go back and you try again. Just keep account of how many oxygens and ions you have each time. If I times that by 2, I'll make that 6 and turn that into an even number. So that's what I'm going to try to start with. I'm going to put the 2 in front of the Fe2O3. That means 2 times the 3 will make it a 6. Okay, that is now more doable for me. But I must not forget, if I've times the whole formula, I've done something to the iron as well. Now the iron's a 1 over here, so whatever I do to over here, I should be able to sort out quite easily with this over this side. So 2 times the 2 will make me 4. Okay, so let's go back onto the left hand side, onto the reactants. So let's sort out those oxygens, because they were annoying me, and I think I can do it now. Can you see we've got 2, and I want to make 6, so I'm guessing that I'm just going to go for a big 3 there. That's going to make that one 6 altogether. Yes, 3 times the 2 is the 6. And if I come and look at the iron, which is in 4 here, it's 1 over here, that should be pretty straightforward. And I'm just going to times that one by 4, so it turns it into 4, and now I have a balanced equation. Like I said, I'm going to explain hopefully more in my next tutorials why we balance and the importance of it. Yeah, but I'll come on to that in a few tutorials time. Okay, give you one to have a go at. These I've just had 2 elements in it and combining to form the 2 elements together. I'll give you one to have a look at, and we can look at this at the start of the next video tutorial. If I give you methane, which is CH4 plus O2 reacting with oxygen, the carbon and the oxygen react together to form a compound known as carbon dioxide, CO2. Then the oxygen and the hydrogen react together to form hydrogen oxide, commonly known as water, H2O. Have a go at this. This time you've got carbon, hydrogen and oxygen to deal with. See if you can do it. Good luck. Try this method. Try it out. Give it a go. Best of luck. I'll come and talk to you in the next tutorial. Start the next tutorial about that one. Thanks.